The third video in the basics of chemistry or chemical basics units is simply on periodic table design, some of the basic design elements of a periodic table. So if you get out your periodic table to go along with this, we're just going to jot some notes down on the periodic table directly that will help you out as you learn how we want to go about using this periodic table. First of all, the design of the periodic table is such that the table is designed into rows going horizontally left to right and columns vertically up and down. These rows and columns have other names. We usually don't call them rows and columns. The columns, so these are the vertical up to down groups here. That's exactly what we call them. We call them groups. Okay, so groups you can see are numbered across the top here. I'll zoom in here a little bit for you. Groups here are numbered across the top 1, 2, 3, 4, etc. over to 18. So you can see there are 18 groups, and we can simply number them 1 through 18 for easy identification. The horizontal rows are called periods. They're called periods. And we can number them simply 1 through 7. 2, 3, 4, 5, 6, and 7. You'll notice that these two rows that are pulled out at the bottom are actually a part of periods 6 and 7. You can see on your periodic table there's an asterisk here for atomic numbers 57 through 70. Okay, those all go here in period 6. Likewise, atomic numbers 89 through 102 all go here in period 7. So one thing you should be able to do is identify elements by their group and period number. So for example, if I asked you which element was in group 16 period 3, you should be able to identify that. If you look over here, group 16, go down to the third period, that would be sulfur. Note, not selenium, because oxygen is in the second period. Sometimes that's kind of easy to mess up, because hydrogen and helium are the only two elements in that first period. So oxygen's in the second period, sulfur's in the third period. So sulfur would be period 3, group 16. Ask yourself, what element would be in group 7, period 6? Give you just a moment to find that. If you told yourself it was rhenium, then you would be correct. Group 7, you can see here, period 6 would be rhenium. So you can think of these groups and periods as a way to identify the location of the periodic table of these elements. Alright, another way these elements are organized on the periodic table is by properties. And one of the most basic properties that we can organize by would be by metals and nonmetals. So you can see here towards the right side there's this dark stair-step line that is on the right side of the table. And I'm just going to sketch a schematic of that up here. Here's our stair-step line. Elements to the left of the line are metals. Elements to the left of the line are metals. So we can see a great majority of the elements that we have are metals. Elements to the right of the line are nonmetals. We can see there are quite a bit fewer nonmetals than metals. And then elements that lie along the line are called metalloids. The term metalloid means a semi-metal or a metal-like property. Now, metalloids, by just saying they lie along the line, that's not immediately clear which elements are metalloids and which aren't. So I'm just going to put a little dot next to them. I'm going to put a dot in their box here on the periodic table to help you identify which ones are metalloids. There are 6 metalloids that we generally, or 6 elements we generally identify as metalloids: boron, silicon, germanium, arsenic, antimony, and tellurium. Okay, so I'm just identifying those with a little dot there, so you can mark those in your periodic table as well. These elements have properties of both metals and nonmetals, and thus we call them metalloids. Alright, something else we should be familiar with is the fact that certain groups have different names that we often identify them by. Group 1 are called the alkali metals. Group 1, the alkali metals. Group 2 are known as the alkaline earth metals. All these groups here in the middle, groups 3 through 12, I'm just going to identify them collectively. Just putting a bracket here. Groups 3 through 12 are known as the transition metals. Groups 3 through 12 known as the transition metals. Groups 13 through 16 do have names. They're not very common though, so I'm not going to worry too much about giving you those. Group 17, these elements are known as the halogens. And finally, group 18 are known as the noble gases. So as far as these group names are concerned, what we should be able to do with them, I could ask you, give me the 5th period noble gas. And you would need to know that group 18 are the noble gases. You need to go down to the 5th period, which would be xenon, and xenon is the 5th period noble gas. So something along these lines. We just want to be familiar with those names because they are often referred to by those group names, whether it be in textbooks or in other readings that you might see. Alright, some other names we want to be familiar with. These elements down here at the bottom, you can see, first of all, there's a name already listed here. This top row are called the lanthanides. The reason they're called that is the first element in it's lanthanum. And then likewise, the second row here are called the actinides. The first element in it's actinium. That's where those names come from. Collectively, both these groups also have a name. Notice, like we talked about earlier, these elements actually go right up here in the periodic table in this spot. So they're within the transition metals. So because of that, much of the time they are called inner transition metals. Inner transition metals. So we have a name for all these elements here in the middle, calling them transition metals, including these here at the bottom. We also have a name for all the other elements. So if we go back up here to the top, notice that would be groups 1 and 2, and then groups 13 through 18. Collectively, those have a name, and I'm just going to write it up here at the top because it's not really a good way to mark on the periodic table. So groups 1 through 2 and 13 through 18, these are oftentimes called the representative elements. And there's a reason for that we'll discuss at a later date, not necessarily in this video here, and we'll see why they are called the representative elements. Alright, one other thing that we can discuss here today as far as the periodic table is concerned, something about atomic structure, something that you learned back in physical science and you might remember it, and if you don't, that's okay. I'm actually going to put these notes here on the back of the table, so if you just want to flip it over, it'd be easier to have a little more room to write this out. We can learn a lot about an element's atomic structure from its position on the periodic table. First of all, we want to know what the term valence electron is. And this is a term you might remember from physical science, and if you don't, that's okay. A valence electron is simply an electron in the outermost energy level. Recall that electrons are organized into energy levels, not really rings around the nucleus. This is an idea we'll get to a lot more when we get to our next video. But the position of an element on the periodic table will give the number of electrons, valence electrons, an element has. So for example, group 1 elements, they all have 1 valence electron. I like to use the notation E with a superscript minus because electrons are negatively charged. So anytime you see this, this means electron. Likewise, group 2, these elements have 2 valence electrons. Now the trend does not continue for the transition metals. One reason why we separate those, as far as why we give them a different name, this is one reason why. So groups 3 through 12, for now what we're going to say, they either have 1 or 2 valence electrons. This is something we'll learn about later in the year as far as how we can determine how many valence electrons they have. For now, it's really not that important to us. They either have 1 or 2 valence electrons. The trend continues when we get to group 13. Group 13 elements have 3 valence electrons. Not 13, 3. Okay, elements can't have 13 valence electrons. That's something else we'll learn about later as far as why that is. So group 1 has 1, group 2 has 2, group 13 has 3, and then this trend continues. Group 14 would have 4 valence electrons, and the trend continues up to group 18 with 8 valence electrons. So all elements that are in the same group have the same number of valence electrons. This is an important idea because this is what groups elements with the similar properties. If you're going to remember one thing from this short video, this would be it. Okay, I'll jot it down here. Elements in the same group have similar properties because they have the same number of valence electrons. Simple as that. So if we flip back to the periodic table side here, let's just talk about the halogens, for example. Okay, one reason why they're given a collective name is because they all have similar properties. Fluorine, chlorine, bromine, iodine, acetine, they all have similar properties because they all have 7 valence electrons in group 17. Another thing that we can learn from the periodic table and its position, the period number. Remember, periods go left to right, so we label the period numbers along the left here. The period number gives us which energy level the valence electrons are in. So, for example, if we're talking about magnesium, I know magnesium has 2 valence electrons because it's in group number 2. I also know that those valence electrons are in the 3rd energy level because it is in the 3rd period. Ask yourself, let's talk about arsenic here. How many valence electrons would arsenic have? If you said 5, that is correct because it's in group 15. Which energy level would those valence electrons be in? Well, if you look over at the period number, scroll back here to the left, arsenic is in the 4th period. 4th period, so those 5 valence electrons would be in the 4th energy level. So that's how we can determine which energy level those valence electrons are at.